So in this series of lectures, this is the lecture number 3. In this lecture, we will discuss the mathematical formulations of our objective functions. So in previous lectures, we have find the optimization function. Okay. So just first write down the what is our optimization problem. After apply the squashing technique, we got this function. So what is our function? Just write down. So we got the our optimal W, that is which is the optimal plane, that is perpendicular. W is that is perpendicular to our optimal plane. So W star is equals to arc max of W summations over I is equals to 1 to n 1 by 1 plus exponentials of minus yi W transpose xi. Okay, this is our optimization problem. After applying the squashing technique, we got it. Okay, now first we discuss about the monotonic functions. If you are already a mathematics student, then I think you will know about it. But if you are not a mathematics student, just then patience with me. So what is monotonic function? So monotonic functions is nothing. It is a function when its argument value is increases, then its functional value is increases. This type of functions is called monotonic increasing function. And similarly, there have other type of, that is monotonically decreasing functions. There have one type of monotonically increasing functions, and also it will be decreasing function. So first, what is monotonically increasing functions? If we increase the value at argument, that is x, then according to that also its functional value increase. If we just assume a monotonic function gx, let's assume a monotonic function is gx, then if we increase its argument, that is x, or we call it as independent variable, then its functional value is increases. So in other language, if we write it, if x1 greater than x2, there are two different values, x1, x2, then g of x1 is greater than equals to g of x2. Okay, then g of x is our monotonic function. Okay, just we have taken an example. So we have taken an example log x. I think you all hear about log. What is log? Just see this graph. What is log x? Okay, this is our log x function. This is our log x function. So you can see this is our x value. This axis is our x axis. This is the x, and this is our log x. Okay, if we increase the value of the x, then just see the value of the log x, it will also increase. Okay, it is a monotonic increasing function. If we just see the point, just first see our mouse. So if we just increase our value of x, then the value of y is also increased. Okay, so this is a monotonic increasing function because we increasing the value of argument, that is x. that is x, just increase in this is x is our actually argument or independent value, then function value is increasing. Okay, just write down, because log x, it is defined in only positive value. So if our argument is increasing, then log of x is also increasing, and if x is decreasing, then our functions is also decreasing. Okay, now let's consider one thing. So what is it? It is our monotonically increasing function. Okay, now just write down a optimization problem. Just taken an example to understand this theorem. Suppose our optimization problem is x. We have to find an x which is the arc minimum of x square of over all x. We have to, this is our main optimization problem, that is we have to find a best x, that is it is our best x among all of the x, it is our best x. Okay, so let's take our functions as name f of x, which is x square. Okay, so this function can be written as similarly, if f of x is equals to x square, this function we can written as f of x. Okay, and if you are a mathematics already student, then you can already know how to define a maximum functions and minimum value, how to find them, if maximum and minimum function of a value using derivative. In undergraduate course we have already learned about it, but if you are not a mathematics student, just see the geometric part of it. Then after this chapter we will discuss everything, what is derivative and how to calculate its maximum, minimum, and how to useful it in machine learning, world of machine learning. Okay, so first see the graph of the x square. Okay, this is our x square, this is our x square graph. So in this graph you can see, just delete it first. Okay, okay, first this is our x square graph. So you can see, if we increase the value of x, just see my mouse, if we first increase the value of x, then in the negative portion of this plane, that is in this side, this is the negative side of our plane, this is the positive side of our plane. Okay, if we increase the value of, if we increase the value of x in negative side, then the function value is decreasing, but in the positive side we have increased, then the function value is increasing. So in negative side functional value decreasing, and in positive side functional value is increasing. So this function is not a monotonic function, because in overall whole the domain, in overall domain, that is in whole region, these functions behave two type of, like, that is in positive side it behave monotonically decreasing, and if negative side it behave monotonically increasing. So it is not a monotonic functions. So if we write in this side, it is monotonically decreasing functions, it is monotonically increasing functions. Okay, so if you see from the graph, what is the minimum value? What is the minimum? Actually the minimum value is here. What is the minimum value of this function? That is here. So what it is? So here you can see from the graph, the minimum value of this graph, that is best x star is equals to arc mean of all the x, f of x, when our f of x is equals to x square. Okay, so what is the minimum value? What is the minimum value here? X star here is equals to our 0, as well as functional value is also 0. Minimum of functional value is 0. So we are not interesting about the functional value, we are just interesting about the argument value, in which argument our function behave like minimum. So our best optimal value, that is best x is equals to x0, that is our best x. Okay, now let's go to another thing. Let's change the color. Okay, now we can see that our log x, first we got a functions log x, that is monotonically increasing function. This log x function is our monotonically increasing function. Okay, now one thing, first we got that x star, just be patient. F of x, when our f of x is equals to what? F of x equals to x square. So what is the value? We see this from our graph, this value x star here, this x star is equals to 0. We see it from our geometrically. Okay, now number 2, what is in number 2, we want to find best x, that is we call it at x dash, that is arc mean of g of f of x. This type function is called the functions of function, or another language you call it as functional composition. Okay, so if we call it this function, this log is, if we rename it as g of x, okay, then what is this thing? Our g of x is equals to log x, and f of x is equals to x square. So this will be log of x square. Now we claim that x star and x dash both are same if our g is monotonic function, that is monotonic increasing or decreasing. First we claim what is claiming? We claim that our x star is equals to x dash, when since g of x is monotonic function. Okay, then we claim it. Now if we write it in mathematical language, so just we write in mathematical language. That is what? Arc of mean of x, f of x, that is x star, if x star is x dash, then arc of mean of x of g of f of x. Okay, similarly if we write down it as max of x, g of f of x. Okay, this will happen when if g is a monotonic function. Okay, if g is a monotonic, then it will only happen. Now just verify, just see this example with an example, so what we got from geometrically, what we got, just go to this page. So what we got in geometrically, the minimum value, the best x is about our f of x is what? Here f of x is equals to x square. And what is our base test for the minimum value of f of x? So our base test, we call it as x star is equals to 0 in this example. Okay, now we just draw the compositions of log x. And previously we see that log x is a monotonic functions. Okay, this is our log x, this is a monotonic functions, and it is a functions. We got it base x. Now we claim that log of f of x, that is g of f of x, because we called the log function as g of f of x, g of x. So g of f of x, now the g of f of x, this is our g of f of x, that is log of x square. Okay, so its minimum value also lies in 0. You can see it from here. So what is the minimum value? This side is also decreasing function, this side is also increasing functions. So minimal value will be here. This will be the minimum value of these functions. Okay, because we claim it, and geometrically we can see it here. You can find this theorem if you want to prove mathematically. You can just Google search it and see the Wikipedia article or any mathematics, basic mathematics book. You can find this for theorem. Okay, here it is the very important theorem. Okay, so the main thing is that why we learn about this theorem. So because first we find this our this is our main functions. We want to find the maximum value of these functions. Now if we apply the some theorem about this function, if we apply this theorem of these functions, then something we have to modify it because of our calculations, easy of our calculations. For making the easy of calculations, we just apply the compositions rule, because at the end of the day we have to find the best w. Okay, so if we apply some functions to find the w, optimal w, if we find a better way or easy way, then why not, we can apply it. So just write down it. So first we write down, again we write down these equations. Okay, so let let our g of x is equals to log of x. That is a monotonic function. And this function, that is our sigma x, is our Gaussian function 1 plus x. Okay, so now we just want to modify this function. W star is equals to argument of maximizing function w summations I is equals to 1 to n log of, that is g of x of this function our is, what is our argument here? I of w transpose, sorry, xi. Okay, actually these functions. So if we write it finally, what is this? F of x summations I is equals to 1 to n log of plus exponentials of minus yi w transpose xi. And we know that log of x is what? Just this is the simple formula of log of x. 1 by x is equals to minus of log x. Okay, so if we apply this formula here, then what we got? Just exp of x, just don't be confused about it. Exp of x equals to similar as e to the power x square minus yi w transpose xi. Now we have to learn another thing. What is this? This is argument of max of f of x is what? This is the similar of, just we see it geometrically. First we write down it, then we can see it. We will see it. F of x. Okay, this is the, we have to apply this formula. Why we write it? Just if we see this graph, just see the graph power. This is the plot of x square. Now just I am applying here. So first see this graph. In this graph we see that the minimum value is here. Okay, that is if we write arc of mean of, if we called it as f of x, arc of mean of f of x for all x, that is 0 is the best x. Now we can just want to change this function, that is we want to change this function as minus f of x. So what will happen? Just click here minus. Okay, so you can see the maximum value here is the same 0. Okay, first we see that it is the, if the here maximum, this is the maximum, this is the maximum value. So if we change it maximum, this will be the similar maximum of f of x minus of f of x. Okay, this is the main thing. Both are the same. We just similarly go to this page. Similarly, we can write it as argument of minimum of minus f of x is equals to argument of sorry, here if you apply, okay, no problem, just max of minus f of x is equals to argument of mean of x f of x. Okay, so just apply this formula. Here we have minus, just here we have to here apply this formula here in this function. Then what will we get? Then finally we will get w star is equals to just apply this function here. In previous one, just apply this rule. Okay, so this is our main optimal. This is the logistic main optimal problem of the logistic equation. This is the main optimal problem of the logistic equation. Okay, so this is what this function is. What this function is nothing is called, this is the signed distance. This is the signed distance. And what is the value of the yi here? So value of the yi here is plus 1 or minus 1. Just we want to just play with these equations now. Okay, if we not used 1 here, then what will happen? If we need 1 here, then log and exponential both are cancelled. Because why cancelled? Because we know this formula, log of exponential of x is equals to x. Actually, log is the main very interesting function in the world of machine learning, artificial intelligence. Actually, in exponential thing, it will transform to linear world. In from exponential world, it will log function is transformed to in linear world. Similarly, if we want to multiply it, then log functions convert it in additions. In log function is what? Log functions convert the multiplication to additions. Okay, this is our main optimal functions. So if we don't use here 1, because why we used to have, because in previous lecture in this from these equations and from where these equations come, actually for our outlier, for avoid our outlier fund, we apply these functions. Okay, if we don't use 1 here, then you can see this function will convert it to, you just write down it. If we don't use 1, then this function will convert it to what? This function will convert it to arc mean w. Log will be cancelled out each other. That is minus yi w transpose xi, and same equations using the above theorem, that is what? This theorem. Using this theorem, you will convert these equations as this. Okay, actually we will see at the beginning of this lecture, this is our main mathematical optimization problem. And from this optimization problem, to avoid some error or mistakes, we will got these equations. Okay, but at the end of the day, these both are the same. Okay, this is functions are huge amount of outlier functions. Okay, in this function we have got the outlier problem, huge outlier problem. To avoid this outlier problem, we applying the squashing technique. How we apply the squashing technique? Just we apply the Gaussian functions of this problem, then we list out these functions. Okay, and we see that to show easy of our calculations, we apply the log functions to convert this exponential thing to a linear thing because of our easy of calculations, and finally got our logistic regressions optimization problem, this one. Okay, I think you are all about clear. If you have any doubt, any problem on this lecture, just comment below. Okay, and I think again I will try to explain it very clearly. Okay, thank you.